Hi guys. So sorry, part two, right? Display setting, duplicate slideshow. Okay, we are back with uh, the same program get. Okay, so you can see buff2, get buff2, and every time you see a space, that is basically a null value, and that is basically a problem. Whenever you use a normal cin, if when you're trying to capture a string, all right, okay. So you can actually do it in another way, which is by using get. Okay, in line number 18, you can see that when I use cin.get buff2, which is basically the array and the size, and now when I print the string read with cin.get was buff2, right? Buff2, and you can see I can capture the whole line, okay, which is taken from after good and space, right? Because the first word here has been captured by buff1 in the very beginning, okay, because you key in the sentence only once, okay, and that's what happened. So you can use get, okay, but there are some limitations to it as well. And you can read this. This is get, but then okay, we have another function which is called getline, which is something that we will be using a lot more when we are trying to tackle the approach of inputting sentences or strings, okay. And you can see here, if same thing, constant integer size 80, line number 9, and then line number 10, we have char buff1 size. I have one array with the capacity of 80 characters. I can store 79 because one is reserved for the n value, the null value, and enter a sentence. Same line, hello Mr. Cock, what's up y'all? Then I use cin.getline, then I use buff1, I maximize the size, which is the second parameter in the function of getline at line number 14. You can also adjust the size with any integer numbers to capture only certain part of the strings if you want to, right? Like for example, if I would like to capture only your first name, right? So, or I mean, only the first 3 characters of your name, then I can just put the second parameter with an integer 3, okay, rather than size, because size basically maximizes the size of the whole array. And after I get line, then the string entered was buff1. Now you get a whole string with no problems, with no such problems as using cin, the standard cin, the standard input function. Okay, now we have read, we have gcount, okay, and you can see here, okay, constant integer size 80, same thing, I'm using buff1 size, okay, enter a sentence. Rather than using getline, I'm using read buff1, and I take 10, okay. So I'm reading only the first 10 characters, including spaces, right? And for read, you have to realize that it will get exactly 10 values without a null value, right? You see, when I key in the value hello, comma, space, what's up man, comma, space, it, space, has, space, been, space, space, long, space, time, okay, right. If you look at the highlighted yellow area, the ones that are captured is basically HELLO, comma, space, WAS, exactly 10 characters, which is very different from using getline or cin, because they reserve one space at the very end to be the null value. But for read, you can actually capture exactly what it is. But the only problem is when you don't have a null value, right? When you try to print it in line number 13, right? See out the string entered was, then line number 13, see out buff1. Not only will you print hello, comma, space, was, you will be printing all the garbage values that is in the 80 array spaces, right? Because if you put a null value, then everything will be nullified from then on. But if you use read, that is basically one of the weaknesses. But it can also be something intentional that you want to use read for, because you do not want the null value to be assigned to the end of the string that you have captured. Okay, so then when you use cout.write, okay, buff1, but you use another function called gcount, cin.gcount, which means to count the number of values that are valid. Okay, and when you use cin.gcount, it will return an integer value, which is 10, and you can print exactly what it is: hello, comma, space, was, right? And you can also use cout.write buff1, and if I put 5, then I'll only be printing the 5 characters that is that has been stored in the array. Okay, so this is read, gcount, and write. Okay, so the next one, okay, you can see here. Let me see, string manipulators. Okay, let's go into string manipulators. Okay, so string manipulators is very much similar to things that you have been using with placeholder in printfs, like %d, %.2f, %lf, then 10.2f, and so on. But they have functions to tackle all these problems. So first one, okay, it is floating point precision. Okay, we can use either the keyword precision or set precision. Okay, so you can see from here, right? Okay, IOStream, you don't I mean, you can use CMath. I'm using CMath because I need it for line number 9. Double root 2 because I'm going to square root some numbers. Okay, 2.0. And IO manipulation is used for these few things. Line number 16, fixed. I'm using it for line number 20, cout.precision. I'm also using it for line number 28, which is set precision. Okay, as you can see here, okay, I have double root 2, which is a variable, and I square root 2.0, and I get the number 1.4142135562, blah, blah, blah. Okay, I have another value at line number 10, a variable called places, which is an integer. So line number 12, I'm going to print square root of 2 with precision 09. End line, next line, precision set by iOS base member function, precision end line. So that's just a statement. 16, cout fixed. Okay, in C++, right, when you do formatting for all these precisions, things are automated. Like, for example, if let's say I have number 1.42000, if you use printf, and if you don't use 0.2f or 0.3f, by default, it will print 6 decimal points, okay, after any number, right, if there is a decimal points. But then when you look at C++, normally some automation happens by eliminating all the zeros, trailing zeros from being printed. Like, for example, if I have 1.2, right, automatically if you print it, you will get only 1.2 rather than 1.200000, which is the case if you use printf, right? Okay, it automatically eliminates any trailing zeros, right? But when you use fixed and together with precision, you are making sure that regardless of what precision you're going to use, like for example, I want 3 decimal points, right? If I use fixed, then for sure it will be 1.200. Okay, if you use precision without fix, still automatically, if there's a number 1.2, you expect the number to be 1.200. It will still be 1.2 because the other 2 trailing zero is automatically eliminated when you use especially Visual Studio. Okay, right, so if you can see here, okay, line number 16, cout fixed, right? 18, for places equals to 0, places lesser equals to 9, plus places. Okay, there's an increment loop. And line number 20, cout.precision places means I'm going to set the precision from 0, 1, 2, 3, 4 by printing the same number over and over again. So technically, I'm printing the number 1.414213562, right, from 0